Many silicones are sold as liquids or pastes that must be cured. Curing means to permanently convert a liquid into a solid by means of a chemical reaction. This differs from freezing a liquid, like freezing water, and from drying, like the ink from a marker. Curing is permanent, non-reversible solidification. Some materials are thermoplastics, which means they are heated to melt and form, and then cooled to hold the desired shape. These materials are not cured. Heat will remelt them. A technical definition of cure is to cross-link polymers. Cross-linking means to create chemical bonds between polymer chains or strands such that an entire volume of material solidifies by connecting every liquid component into one structure. Silicones cure in several ways, each with their own advantages and limitations. We will walk through these main cure types of Dowsil products used in the electronics industry. We will start with one-part condensation, commonly called moisture cures, and sometimes called RTV, which stands for room temperature vulcanization. Vulcanization means curing a liquid into a solid. The acronym RTV is commonly used for moisture cure products, but can be used for any room temperature curing material, and so can be confusing. All moisture cures are RTVs, but not all RTVs are moisture cures. Moisture cure silicones are the most common types of caulks and sealants and have several subcategories: acetoxy, oxime, and alkoxy. Moisture cure products are one part and use a titanate-based catalyst to speed the cure. Acetoxy cures often also contain an organotin catalyst to speed up the tack-free time, skin over time, or surface cure speed. These products only cure in the presence of moisture in the air or humidity. Cure proceeds from the exposed surface inward. Therefore, they will first form a thin outer skin of cured material, creating a dry-to-the-touch surface. Once this skin forms, the material can continue down production lines as the cure will finish by itself as long as it is in contact with moisture in the air. While the surface will be cured and dry within minutes, full cure is slow, progressing at about 1 millimeter of depth per day. In highly confined applications with only limited air exposure, full cure can take several weeks. Moisture cures are the simplest to use, as once they are dispensed, the cure will progress to completion as long as the product is exposed to moisture in the air. They have good adhesion to most metals and many plastics, with specific formulations targeting more difficult-to-bond plastics. The main limitation with moisture cures is their slow cure. They also have from 3 to 5% shrinkage during cure due to the leaving groups, which are also called the cure byproducts. Because of the slow cure and volatile byproducts, moisture cure rates can only be accelerated with mild heat, such as 60 degrees Celsius. Higher temperatures during cure can create voids or bubbles. A subset of moisture cure is moisture curable silicone hot melts. These products are heated to make them flowable for dispensing and solidify to a sticky putty consistency at room temperature. They develop adhesion as they cool and show good adhesion strength in minutes after dispensing to nearly any surface. They have a slow moisture cure which creates a non-tacky surface and prevents them from remelting after full cure. Some limitations of silicone hot melts includes long time to full cure, heated dispense required, and adhesive failure rather than cohesive failure. The second cure type we will discuss is two-part condensation cure, sometimes referred to as tin cure, due to the organotin-based cure catalyst used in these products. These are typically supplied in mixed ratios of 10 parts of base to 1 part of catalyst. Tin cure products do not need exposure to moisture in the air and are designed to cure at room temperature at any depth and any level of confinement. Silicones have an extremely low cure exotherm, so large volumes of tin cure silicones can be cured with no danger of overheating. While many tin cure products cure within minutes, those with built-in adhesion, called self-priming, require more time for adhesion. Newer adhesives achieve strong adhesion in 24 hours, while others require 3 or more days for adhesion to build. Tin cure products can obtain their other properties well before adhesion. The main benefits for tin cure products are that they cure fast at room temperature, cures at same rate throughout the material, cures in confinement, and faster adhesion development than one-part moisture cures. There are, however, some limitations of tin cure products. Adhesion can take up to 1 to 3 days to develop fully, can also show signs of depolymerization, called reversion, at temperatures above 100 to 150 degrees Celsius when used in low to no oxygen environments. The third cure type we will discuss is called addition cure, or sometimes platinum cure due to its organoplatinum-based catalyst. These are 1 or 2-part, and some formulations must be cured with higher temperatures, while others can be cured at room temperature and greatly accelerated with heat. Nearly all Dowsil encapsulants, gels, and conductive products used in electronics are addition cure, as are many adhesives and some conformal coatings. Addition cure is very versatile, with the ability to adjust many parameters by formulation, such as 1 or 2-part systems, very short or very long working life, room temperature cure time from 10 minutes to days, and heated cure times from seconds to hours. Addition cures generate essentially no heat and do not need exposure to the air or moisture as they cure. They can be cured at any depth or volume required. Unlike moisture or tin cure products, the speed of addition cures can all be dramatically accelerated with increased temperature, and the higher the temperature, the faster the products will cure. The main benefits for addition cure products are that they can cure fast at room temperature, cures at same rate throughout the material, cures in confinement, and faster adhesion development than one-part moisture cures. There are, however, some limitations of addition cure products. High temperature heat cures are required for most adhesion. Cure can be poisoned by certain contaminants, and some products are 2-part. The fourth cure type we will discuss is called ultraviolet cure, or UV cure. UV cure products contain an ingredient that absorbs energetic UV light and breaks apart into chemically reactive species that cause the cure to be done in seconds to minutes, depending on the strength of the UV light and the depth of the material being cured. Many UV cure products have a secondary cure, sometimes called dual cure. This is often moisture cure components, which will solidify the areas where the UV light could not reach. These areas will cure like other moisture cures at about 1 millimeter of depth per day. Having both cures in one product ensures all areas will cure and parts can continue to be processed immediately after UV curing, since the moisture cure will continue and finish by itself. Dual cure products are becoming more common, making it possible to combine benefits from each cure type. Another dual cure system comes with our thermal radical cure, or TRC, products. Thermal radical cure uses a peroxide to initiate the cross-linking and cure. This allows good adhesion to plastics. It is also a dual cure, using moisture cure ingredients to get good bonding to most metals and to complete the cure at the surface. Thermal radical cure materials can be thought of as curing from the inside out, the opposite of moisture cures, which cure from the outside inward. This allows adhesion to build on many surfaces as soon as the solidification occurs. Oxygen in the air creates a tacky or even wet outer surface for these adhesives, and the moisture cure will complete the surface cure and make it non-tacky within a few hours to 1 day. Thermal radical cure allows for fast cure at low oven temperatures, with great adhesion to plastics and many metals, and is not impacted by contamination that can cause cure poisoning in addition cure materials. The surface may remain tacky or sticky for a day as the secondary moisture cure completes. We have covered the most common cure types for Dowsil products. All of these cure systems have unique advantages, and there are many new cure and dual cure systems being developed.